Okay, so in this video we're going to look at the fundamental principle of counting, and then we're going to look at some examples of permutations or arrangements. So let's just start with the fundamental principle of counting, which is kind of a fancy name for something that's really very simple. The definition of the fundamental principle of counting is that if you have m possible outcomes for one event and n possible outcomes for another event, then the total possible outcomes is m times n. So for example, if you go into a restaurant and there's a very simple menu put in front of you where you've got 3 main courses and 2 desserts. So that's all you can choose from, 3 main courses and 2 desserts. Well, you can have the first main course with the first dessert, you can have the first main course with the second dessert, second main course with the first dessert, second main course with the second dessert, third with the first, third with the second. So that's 6 in total if you were to list them all. But really the fundamental principle of counting just says all you've got to do is multiply 3 by 2. So 3 times 2 is 6, so you've got 6 choices in total. So you can list them all, or you can just simply multiply 3 by 2. Multiplying is obviously a lot quicker. Okay, so that's really the fundamental principle of counting. So what we're going to do now is look at arrangements or permutations. So I'm going to take some examples. Let's look at the word history, H-I-S-T-O-R-Y. So that has 1, 2, 3, 4, 5, 6. That has 7 letters. So how many ways can we arrange these letters? They're all different, so we can arrange them like we can arrange them in this kind of order, H-I-S-T-O-R-Y. We can arrange them Y-R-O-T-S-I-H, and so on. We can arrange them in numerous different ways. So let's see how we would go about that. Well, if we take we can look at maybe something like this. We can draw little boxes here. We've got 7 letters, so let's draw 7 boxes here. So that's 1, 2, 3, 4, 5, 6, 7 boxes, and we're going to multiply the numbers that we get here, and we'll see what we end up with. Now, look at the first box here. What we're going to do is just look at how many possibilities have we got for our first letter in our arrangement. Well, we have 7 letters to choose from for our first letter, so we put 7 in here. Now, once we choose one of these letters, so say for example we've chosen for our first letter S, so we've removed S, how many letters have we got left to choose from? So for our second choice then we've got 6 left to choose from. So if we removed say the S and some other letter, say or, how many letters do we have to choose from? Well, we've got 5 left to choose from, and so on. So we've got 4 here, 3 here, 2 here, and 1 here. So what have we got? We've got 7 times 6 times 5 times 4 times 3 times 2 times 1, which gives us a total of 5,040. So we've got 5,040 possible arrangements of the letters of the word history. Now, the way we can write that is 7 factorial, which looks like this, 7 factorial. And this factorial symbol here, you should be able to find that on your calculator. There should be a factorial button on your calculator. So all you've got to do is type in 7 and then this button here, press equals, and it'll do 7 factorial for you. It'll do 7 times 6 times 5 times 4 times 3 times 2 times 1. Press equals and you should get 5,040. So we've 5,040 ways of arranging the letters of the word history. Okay, so that's our first example. Now, let's have a look at another example. Say we look at, take another example here. We look at the letters P, Q, or S, T. P, Q, or S, T. Now, if we want to arrange these, we've got 5 letters here, okay? So if we want to arrange all 5 with no restrictions, it would be just 5 factorial. But what I want to do in this example is we want to just take 2 letters at a time. So for example, we're going to take, for one arrangement we could take is just PQ. Another arrangement would be RT. Another arrangement would be SQ, and so on. So we're only going to take 2 letters at a time. So how can we do this? Okay, well, there are a number of ways of doing it. So I'm going to use this box method first of all. So what I'm going to do is just draw two boxes first, because we're only taking two letters at a time. So what you do is look at the first box here. How many possibilities have we got for our first letter? Well, we've got 1, 2, 3, 4, 5 letters. So for our first letter, we've got 5 choices, five letters to choose from. Now, once we take away any one of these letters, we've chosen one letter, it doesn't matter which one. How many have we got left then for our second letter? Well, we've only got 4 left. So that's it. We're only taking 2 letters at a time. So our answer will be 5 times 4, which is 20. So that's one way of doing this problem. Now, a second way of doing it is just simply to use your calculator. Now, on your calculator, again, you should see a button that looks something like this. So it will be, you'll have a letter up here, usually N, P for permutations, and then usually OR down here, NPR. So if we want to arrange from 5 letters, we want to arrange them 2 at a time. So what you would type in here is 5, and then you would put in your 2 down here. Okay, so you press this button and it'll should allow you to put in a 5 up here, a 2 down here, so that will also give you 20. Okay, so that's 2 ways of doing the same problem. So let's have a look at a third way then. There is a formula you can use. So the formula you can use then is, it looks like this. So you've got n factorial on the top, and then on the bottom you've got n minus or factorial. So what does that mean then? Okay, so let's have a look at that. N factorial is this number here, which is 5, the total number of letters you have to choose from. So you're going to put 5 on top here, and you're going to get the factorial of that. And then n minus or, so in other words, you're going to take 5 minus 2 in this case, or this letter, this n minus or here, whatever is here, subtract this letter from it. So it's 5 minus 2, which is, that's 5 minus 2 here, I'll put that there, and we're going to get the factorial of that. So you're looking at 5 factorial on the top, you're looking at 5 minus 2, which is 3 factorial on the bottom. So if we do that, 5 factorial is 120, 3 factorial is 6, so 6 into 12 goes 2, and 0, so you still get 20 here. Okay, so that's 3 different ways of doing the same problem. You could also try listing them, but the problem with listing them, as these problems get bigger and bigger, chances are you're going to miss some of them. So it's best to use either this method, or this method here to work out what the possible arrangements are. Okay, so that's it really for the fundamental principle of counting and the permutations or arrangements in this case. Okay.